2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome, and another great welcome to you all out there, whenever you might be watching us. Maybe you're watching us on the show. I'm Ernie Roberts, by the way. Maybe in our normal, we'll get it right, normal time slot, or perhaps you're watching it on YouTube. We are glad you've tuned in, and you know, it's test prep week here. Actually, it's test prep month. Say that a few times. We won't try it there. But you know, we're glad you're here because we're here to help you get through those EOCs, those SATs and ACTs. And you know, you can catch us anytime on YouTube, but I'm glad you tuned in to watch us on the show today. And let's see what kind of skills we're going to focus on in this show. Quick Quadratics. Quick Quadratics, we're going to call it. And we're also glad to have Bearden High School students here with us today that are going to help us, well, they're going to give us some questions and problems for us to work out with you, all right? And the idea of Quick Quadratics is we want to make this a fairly quick review. We're going to go through some different methods. And hopefully by the end of the show, you'll have it down pat, ready for those ACTs, SATs, and end of course tests where you got to do all sorts of great things. So let's see what our first situation is with our quadratic equation. It says, what are two solutions of the equation? It says 3x squared plus 33 equals 45. Now, when we look at that, sometimes we get a little nervous because we see 3x squared. A lot of times we'd like to have that x squared by itself. Never fear, we may still get there, all right? But if not, we'll work out some ways to get there. But here's the deal. Let's write it down. And by the way, while you're at home, or wherever you might be watching this great video here, we want you to be sure to take some pencil, paper, and do some writing. And also, if you've got a graphing calculator, you can check yourself with a lot of these things too. So let's put it down. 3x squared it is plus 33 equals 45. Now, first thing I notice, and hopefully you guys are also out there watching us today, there is no, quote, linear term. There's not something x floating around in this problem. There's a quadratic, which is our 3x squared. There's a constant and another constant, which is very nice because what we're going to do, we're just going to play the game, get x squared by itself, then square root. Hopefully it'll come out nice and even. We'll find out. So let's do that. Let's subtract the 33 because it's certainly keeping us and it's also making us nervous, right? Everybody says, yeah. So let's go ahead and subtract that 33 from both sides. And you're seeing, we're all seeing 3x squared left. And then subtract it out, you get 12. Already this looks a little bit nicer. And you know, that's the same thing you would have done if it had been 3x plus 33 equals 45. You would have simply subtracted 33 from both sides. That's what we're doing. Now, again, remember our point is get the variable by itself. I've got a 3 that's kind of messing me up. You know, I need to divide because it's hooked in by multiplication, so we're going to divide it out. Divide it out both sides. Good old division property, equality, you got it. And what's happening is x squared equals to 4. Everybody with me? It's real easy, isn't it? 12 divided by 3. Now, we're thinking, what number times itself would give me 4? And notice it's got x squared, which is a hint. There's 2 answers. There's 2 possible solutions. Don't tell anyone. Oh, tell everyone. Let's see what we've got here. X will equal, well, 2 squared is pretty obvious, so 2. But also, if you take negative 2 times negative 2, you also will have fun and games going for you there. It also gives you 4. Quick look, does it work? Put a 2 in there and square it, then multiply by the 3. Remember, order of operations say we square, then we multiply by that 3. So it's going to give me 12. 12 plus 33, got 45. Put that negative 2 in there, and remember, if you're using a calculator for this to check, that's fine. But remember, you got to put the negative 2 and put a parenthesis around that negative 2, then square it, which is going to get you back to 4. 4 times 3, 12, add 33, 45. They both are good answers. They check out very well. It does give you 45, honest. I wouldn't lie, okay? So, as I said, we have some folks from Bearden High School that are doing some things for us on these questions that we're going to ask today. So, hey, I think it's time to let's hear from one of them.
Hey Mathline, this is Christopher from Bearden High School in Knoxville, Tennessee. I have a question for you. What are the solutions for the equation x minus 5 squared equals 25.
X minus 5, and notice the way he said that. He said, as there's a parenthesis around there, the x minus 5, then we raise it to the second power equals 25. Christopher, thank you for your question there. Let's address this one. Let's see what we're going to do with this. It's, first of all, very tempting, and you could do this, my friends. You could do this. I'll show you we could do this. It's very tempting to go ahead and say x minus 5 times x minus 5 in a parenthesis. And while we're at it, I've got a moment here. If we did that or you do that, some of you, like I said, working these along the way at home, that's fine. We're going to show you an easier way, all right? But let's see. That, dear friends, is what that means, okay, when we multiply that out. It's not saying x squared and 5 squared and we get, wow, x squared plus 25 and we're done, because it really doesn't take us anywhere. We've got a little space in between, so if you're going to try it this way, which you can do, I have nothing against you doing it. It just takes a little more time, what we're going to show you. You're going to get x squared from the front end. We're going to FOIL, but now go inner and go outer. They don't disappear. They're not gone. It's minus 10x, and that minus 10x is a quantity that we have to remember, it's got to deal with. The only time it disappears is if x is 0, and we're looking at x being a lot of different possibilities. So that's another point. Now, let's go to that minus 5, that negative 5 times negative 5. That's going to give us plus 25. And that, folks, that's how we get what we're looking for. Now, we could write that all out there. In fact, why not? Let's do it. We could do x squared minus 10x plus 25 equals 25. And you know the story. We can't get rid of x squared, so we've got to have this thing set equal to 0. We got a 25 that needs to get out of there. So we're going to subtract that 25 from both sides, and we're going to have panic in the streets. I know, because here we go. X squared minus 10x equals 0. You got what you wanted. You got a 0. But we lost the 25, and we lost everything. We come up with a 0 by doing this. So what are we going to do? We're going to notice there's a common factor there. There's a common factor of x. We're going to pull it out of GCF moment, and we're going to write that minus 10 equals 0, all right? Divide x, x times x gets you that x squared. X times that negative 10 gives you the negative 10x, or the minus 10x. Therefore, now we can solve. And we've got x equals 0. That's pretty straightforward. We have x minus 10 equaling 0. And that, dear friends, and Christopher is going to give us 0 and 10. Now, I said that was one option. So now, if y'all will lower my lower third out, let's look at an easier way to do this. Folks, and everybody watching, you are already in a squared mode. So what we're going to do, oh, by the way, does it work? Some of you are probably wondering, does it work? Of course it does. I wouldn't lie to you, would I? Let's look at it. 0 minus 5 is 25, right? When you put negative 5 times negative 5, you get 25. Works great. Put a 10 minus 5, gives you 5. 5 squared is 25. So life is good. We know that's the solution. Let's look at, I think, what's an easier way. We've got this thing ready to go, so we're going to square root both sides, because that will give us x minus 5 without a parenthesis. In other words, we're going to basically let the squared and the square root cancel each other out. On the other side, we have an important moment. Be sure you put plus or minus 5, because the square root of 25 in an equation sense here with this x squared going on, you've got to look at two options, the positive and the negative. Now we will finish it off here. We're going to say we're going to add 5 to both sides. This gets kind of complicated with all these 5s, doesn't it? But it's not so bad. 5 plus or minus 5. They're your solutions. Let's see what happens. When we add 5 plus 5, we get 10. When we say 5 minus 5, we get 0. So when you see a question in this format here, you've got a head start if you will go ahead and take the square root out of that. You don't have to worry about the foiling, the distributive property. Oh my goodness, making sure you didn't cancel out the middle two terms, the inner and outer terms, that kind of thing. That's very, very important to watch out for. So, and we get the same solution. I think it's an easier way. So Christopher, you got two options there, two ways to look at it, and hopefully the rest of you chose one of those two to go after. There are other ways we probably can figure it out, but those are probably the most likely the approaches we'll take. I'm ready for another question, all right? Let's go for it. We got them?
Hey Mathline, I am Emma from Bearden High School in Knoxville, Tennessee. How do you solve the quadratic equation x squared minus 3x minus 4 equals 0 by completing the square?
All right, Emma from Bearden High School, thank you for being with us today. X squared minus 3x minus 4 equals 0 by completing the square. So we're going to do just that. If you'll notice here, the big thing is, how do we complete the square? What's that mean? Well, what we're going to start with, we're going to go ahead and let y'all write the question down, which is x squared minus 3. Boy, Emma, I wish you'd given me minus 4x. That would be so much easier. But that's okay. We're going to use an odd number in there. And let's see. Minus 3x minus 4 equals 0. Now, remember the first thing we got to do, we need to basically have x squared and something x all by itself before we can complete the square. So we're going to move this 4 over to the other side. Now, it's a minus 4 here, so we're going to add 4 to the other side. This is going to leave us with x squared minus 3x, and I'm going to leave a gap right there, okay, equals to 4. In other words, we add 4 to both sides. You say, well, that wasn't so hard, and it isn't. It's not hard. Now, here comes the moment. And why did I say, Emma, I wish you'd given me a 4 next to the x, or something even? Because what we're going to do, we're going to divide that 3 in half. And you know what the problem is in some of our minds. Oh my goodness, what do we do? Well, we're going to deal with it. You've got to take half of the 3, which we're going to call 3 over 2, a negative 3 over 2, and we're going to square it. So when we say negative 3 over 2 and we square that, that's going to give us 9, folks, over 4. And it's going to go positive. So we're going to add 9 over 4 right there. And the next thing is we're going to add 9 over 4 out here also. Now, this is where things get a little bit more creative, fun, interesting, whatever you wanted to say about it, all right? Got to go back to, you got it, 4th and 5th grade arithmetic, we got to add fractions. And some are going, oh no, we don't want to add fractions. Well, you know, that's like adding 16 over 4 and 9 over 4. And I believe we're going to have 25 over 4. And you say, what did you, Ernie? I got a common denominator, put a 4 there. I've got to multiply that 4 by 4. That gives me 16. 16 and 9 gives me 25. Now over here, I still have this craziness. I have this x squared minus 3x plus 9 over 4. But the good news is we put that in as an x minus something squared. That's the beauty of when we use completing the square. We can come back and write this, whatever the square root is, of 9 over 4. Now you say, Ernie, why'd you put a minus there? Because I've got to get a minus 3 in the middle. Okay, if that had been a plus 3x going there, we would be using plus here, all right? But we are looking for something that will repeat itself, and 3 over 2. We've already worked that part. There we go. Now, take a hint. I will always take a hint. Let's take square roots. Let's take square roots. I have, Emma, you got it? I got x minus 3 halves. Because remember, those little guys cancel each other out. That's the beauty. Over here, I need to put a plus or minus on that square root. And that's where we got to be careful, because we're going to get 2 solutions. We got 2 solutions, so quadratic, right? So here we go. Here we go. Plus or minus square root of 25. We made it nice for you. Thank you, Emma. And square root of 4 is going to give us a 2. So at this point, here we go. X equals 2. Let's move that 3 halves over there. You were going, oh no, not more fractions to add. This one's going to be nice. We're going to put 3 over 2 to the other side, and we're going to take plus or minus this 5 over 2. Now, that was nice because these were perfect squares. You know, it says it doesn't always work that way. Sometimes you get a crazy square root thing. I tell you this, go to the quadratic formula when that happens. But this one works nice. This one's pretty good. This is going to leave us with, if we say 3 plus 5, first of all, take 3 plus 5, it's going to give you 8 over 2. Life is good because that comes out even, doesn't it? You all got it. All right. Now, what about the other one here? We've got 3 minus 5. That's going to give us negative 2 over 2. And let's go ahead and simplify them. Why not? So in this case, our x value is equal to what? 4 or negative 1. And that is your method. That's your method for completing the square. Now, you know me. I want to know, do they work? You want to know, do they work? Let's put a 4 in here. 4 squared is 16. Minus 3 times 4 gives you 12. So let's see, 16 minus 12. In my brain, that gives me 4. Hopefully in yours too. Subtract another 4, you're at 0. Ding, ding, ding. That's good news. Negative 1, be careful. Negative 1, square it, you get 1. Negative 1 times negative 3, you get positive 3. So we're at 1 plus 3. Da-da-da-da. Oh, you didn't think you'd ever have to add 1 plus 3 ever in high school, did you? Well, you do now. 4 and subtract 4, down to 0. Both answers check. So again, there's your option, and that's your method, completing the square. Thank you, Emma. All right, let's go for another one here. I'm enjoying this. Bearden High School students with us today.
Hey Mathline, it's Hannah from Bearden High, Knoxville. How do you solve the quadratic equation x squared minus 3x minus 4 equals 0 by the quadratic formula?
Ah, Hannah, thank you. X squared minus 3x minus 4 equals 0 by the quadratic formula. Now, if you're watching all these set together, you're going, didn't we just do that problem? We sure did. Now, Hannah's asking it from a different standpoint, a different method. We're going to use the quadratic formula. And if you'll notice, we have it ready to go. If you're at home, go ahead and copy this one down. X squared minus 3x minus 4. If you're driving, don't do it. If you're watching me while you're driving, it's scary anyway. But if you're watching it on YouTube, write it at home also. Now, over here, what we're going to have to do, the quadratic formula, first of all, is a nice little method that we can use the coefficients, which in this case are going to be A, B, and C. All right, and we have this lovely formula. Sometimes we can hum tunes to it, but it's opposite B plus or minus B squared minus that 4 times A times C all over 2 times A. You're going, Ernie, I don't see an A, B, or a C here. Yes, you do. Yes, you do. Our values, here we go. A is the coefficient right here. A equals 1. B is the coefficient of the x, the linear term. It's a negative 3. And C, in our case here, is going to be negative 4. So these are the values that we're going to be able to pull out of the fire, so to speak, and make things happen. Are you ready to make things happen? Of course you are. You're watching Mathline. What more can you want? So let's do it. Let's make things happen on this. Now, if I recall from the last problem, we are supposed to end up with what? X equals 4 and negative 1. Let's see if it happens, right? It should. They're valid expressions. In fact, the quadratic formula was developed off of completing the square, the process. So let's play it out. Let's play it out, see where we go. The storyline here, use the formula. Why not? Let's go ahead. Say x equals opposite of b. Now reason, let's point out something here. Opposite of b. I didn't say negative b, because if you put a negative b down there, you're going to be inclined to put a negative 3. The opposite of negative 3, or the negative of negative 3. You can look at it that way, but you got to make sure you put the right sign. In this case, by the way, that's a 3, not a negative. All right, it's going to become the change. It's going to change signs to positive. We got plus or a big minus there. Well, why not? Let's go ahead and put negative 3 in there, and we'll square it. And once again, notice I put a parenthesis around there because we don't mess up. Nope, don't want to mess up at that point. Minus 4 times A, well, A is 1. That was easy. And C, we have a negative 4. And, oh my goodness, life will be good. Maybe, we hope. All over 2 times 1. That's all we're doing. Substitutions. Easy rote substitutions. See what happens. We got 3 hanging on. Don't do anything to it yet. Let's work inside that radical. Let's see what's happening here. Negative 3 squared. I get a 9. I get a positive 9, right? Yeah, put a positive 9 down there. I have negative 4 times 1 times negative 4. That's going to give me 16. And it's a plus 16, right? Because negative times a negative, you go positive. Be careful with your numbers. Over 2. 2 times 1 hadn't changed. It's still going to be 2. Now, what is 9 plus 16? We can do that in our head, right? It's mental math. 25. Square root of 25 is 5, right? And we're accounting for that plus or minus, right? That's part of the formula. All over 2. This kind of sounds like what we did a minute ago almost. Let's do it. 3 plus 5, we get 8. 8 divided by 2. How about it? We get 8 over 2. We also get negative 2 when we say 3 minus 5 over the 2 gives us, well, you got it, 4 and negative 1. And that's what we had on the other page, wasn't it? Now, notice something here. I kind of went off to the side here, but follow the tracks there. Once you get A, B, and C, and by the way, you got to set it equal to 0. Now, the completeness square, we had to move the 4 over. This time, you got to have it set equal to 0, just like when we try to factor that thing, all right? And by the way, we could factor that too. Comes out nice and even. So 3 options: factoring, quadratic formula, completing the square. And you know what? You could type it in your graphing calculator and see where does it land on the x-axis. Guarantee it'll be at 4 and negative 1. Hey, 4 ways to solve a quadratic equation right there. So let's go one more here, all right? Got one more time for question, one more here.
Hi Mathline, this is Addison from Bearden High in Knoxville, Tennessee. What are the 2 solutions to the equation 2x squared minus 8x equals negative 6?
Woo, Addison. That requires a little bit of work or a little thought, it seems like here. Addison, Bearden High School, thank you for being with us there. And we have, first of all, the problem staring at me beckons that we can go any way we want to, right? We could factor this thing, we could complete the square, we could quadratic formula. Wow. But first thing I'm going to do, since this has this 2x squared involved here, I sure would like to get it out of the way. I sure would like to get that 2 out of the way. It becomes much easier to do everything with. So I'm going to shoot for setting equal to 0. So copy the problem down at home. 2x squared minus 8x, put a plus 6, equaling to 0. I notice all these are even numbers. That's nice. That's why we learn little things about divisibility of 2, 5, all those kind of numbers. This time it's divisible by 2, each of these are. So pull the 2 out, and you know what happens? When you divide 2 into 0, you still have 0. So what we have basically here is x squared minus 4x plus 3. That looks a lot nicer than this does. That's a division property of equality coming to rescue us, all right? Take care of us. It's really good stuff. Now, you say, well, Ernie, what about the 2? The 2 got absorbed by the 0. We don't worry about it. Now, for those of you who want to leave it out there, 2 equals 0 makes no sense, all right? So it's just a factor, but it's not going to have anything, an x attached to it. So we're not worrying about 2 being an answer or something like that. What we want to work with is this guy right here. So we're going to break it down to equal 0. Some of you are still a little nervous about that too. We just divided everything through by 2, and 2 into 0. So let's go with it. X and x. We're going to factor on this one. Since we've been doing all these complete the square and quadratic formula and square root business, let's just do a good old hardcore factoring here. 3. Not very many ways we can get 3, Addison. Gave me a nice one here. 1 times 3 is what we're looking for. And it's got to be positive, which tells me the signs when we multiply have to be the same in order to get positive. Now, it could be positive, positive, or negative, negative, but this little guy here at negative 4 is saying better be negative, negative. So let's put it in there. Minus 1, minus 3. We are good to go because we're going to say x minus 1 equals 0. X minus 3 equals 0. I'm getting x equals 1, x equals 3. Now, I mentioned something about graphing. Let's go to the grapher real quick, see if I can feed this thing in there. We're going to put in Addison's 2x squared. He said minus 8x. And since we're going for the equals 0, we're going to put that plus 6 right in there. And we're going to graph it. And we're going to see, did it cross where we think it should? Here it goes. Look at that, my friends. There's 1, there's 3. Where did it cross the x-axis? Oh my goodness, you can do a quick trace on that if you want. Let's do real fast. We put a 1 in there. Do we get a 0? We'll find out. Yes, we do. Put a 3 in there. Hit enter. You get a 0. The roots, the solutions are what we call our nice little roots on that. In other words, it's where it lands on the x-axis. Those are our zeros of the function. Addison, thank you for that question. And Bearden High School, thank you for being with us today, all right? And I understand they're going to be for a few other shows along with us too. They've got some great questions. And if you'd like to do that sometime, join us. Again, remember, Facebook, hey, we're still around. Mathline online and also YouTube. Be sure to check us out there. This episode will appear. Again, thank you for tuning in this time. We will see you once again next time.